Now let's go for the second method to identify the domain and range by using the nature of the functions, that is algebraic approach. So let's say we have this example. So we have linear functions y equal to 3x plus 5. So if you notice that y is defined for all values of x, so the domain of f is all the real number. So when you change the subject as x, so you have x is equal to y minus 5 over 3. So y also can take any values for x defined. So therefore, the range of f is also all the real number. So what about the quadratic function? So we have y equal to x squared plus 5. So from this function, we know that y is defined for all values of x. So we have the domain of f is all the real number. But if we change the subject as x, so x we get x is equal to plus minus square root of y minus 5. So this is third function. For third function, there is condition. So where y minus 5 should be greater or equal than 0. So we get y should be greater or equal than 5. So therefore, the range of f is greater than 5 or 5 to infinity. For cubic function, so y is defined for all values of x. So the domain is all the real number. So same as for the range. So the range of cubic function is all the real number. For third function, y is defined when 2x minus 3 is greater or equal than 0. So therefore, x should be greater or equal than 3 over 2. So meaning that the domain of f is 3 over 2 up to infinity. So when we change the subject to x, then we get, when we change the subject, if you look at this function, y is equal to square root of 2x minus 3. So meaning that y is always positive. So y cannot take negative value. So therefore, y is greater or equal than 0, always greater than 0. So we can write as the range of f is from 0 to infinity. So for absolute value function, so let's say we have y is equal to modulus x minus 7. So y is defined for all values of x. So get the domain of f is all the real number. But if you notice that modulus means y will take only positive value. So same as third function, so y is always greater or equal than 0. So the range is from 0 up to infinity. So now for reciprocal function, so we know that reciprocal function has condition. So this x minus 6 should be cannot equal to 0. So therefore, y is undefined if x equal to 6. So therefore, the domain of f should be all the real number except 6. Or you can write as from negative infinity up to 6 union 6 to infinity. To find the range, so you can change the subject to x, then you get x is equal to 2 over y and then plus 6. From this 2 over y, so know that y cannot take 0. So therefore, the range of f is all the real number except 0, or you can write as negative infinity up to 0 union 0 to infinity. So lastly, we have piecewise function. So piecewise function, so let's say we have x, for x in between -3 to 5, -3 is included, and x minus 2, for x in between 5 to 9, 5 is included, and another one x squared minus 75 for x greater than 9. So if you see from this, okay, so this is actually give you the domain of the function. So it starts from -3 up to 5, and then 5 to 9, and then 9 to infinity. When you combine this all, then you get from -3 to infinity. So this will give you the domain of the piecewise function. So for the range, you can see that is if f -3, then you will get -3. When f5, you get 5. So for f5, for the second function, you will get 3. So for x equal to 9, so you'll get 7. So and then if you substitute 9 here, then you get 6. So as x approach infinity, then you get x also approach infinity as well. So from this value, so you find the lowest value of f of x. So see, that is -3. So -3 is the lowest value for f of x, and the highest value for f of x is infinity. So therefore the range of f is from -3 up to infinity. So that's the end of our first hour lecture. So that we have to achieve. So within this first hour lecture, so you must know how to define a function, how to identify a function from the graph by using vertical line test. So you must know how to identify one-to-one function by using algebraic approach or horizontal line test, sketch the graph, and the last one is state the domain and range of a function. That's all for the first hour lecture. Thank you. So now please answer this question and send the solution as a proof of your attendance. So the question is, sketch the graph of f of x equal to modulus x plus 5.